Hey everyone, welcome back to the channel. Today we're looking at the MARK4 V2 10-inch carbon fiber drone frame, a lightweight but super strong base designed for freestyle and long-range FPV builds. I'll show you what makes this frame special, how far I've gotten with the pre-assembly, and also how I'm building 2 more frames as practice to get ready for the full project. F722 Flight Controller and 55A/60A ESC Stack Overview. The F722 Flight Controller Stack is a high-performance open-source system designed for professional and hobby-grade drones using the Betaflight firmware. It combines advanced flight control capabilities with a durable, high-current electronic speed controller ESC for smooth and precise flight performance. Built around the STM32 F722 RE6 microcontroller, this flight controller offers powerful processing performance and efficient data processing. The MARK4 V2 has a 427mm wheelbase, which supports 10-inch props. That means it's ideal for high-efficiency long-range flights, while still agile enough for freestyle. The whole frame weighs only around 227 grams, thanks to 3K carbon fiber construction. The design features 3mm bottom plates, 2mm top plates, and 6mm thick arms, giving you an excellent balance between stiffness and vibration damping. It's built to fit standard 30.5 by 30.5mm or 20 by 20mm stacks for your flight controller and ESC. This makes it compatible with popular components like the F4 V3S flight controller, BL Heli_S45A/60A4 in 1 ESC, and VTX 1001W video transmitter. Basically, it's a frame that can handle powerful 6S setups, carry a GoPro, and stay stable even in windy conditions, perfect for long-range mountain flights or cinematic freestyle. So far, I've done a partial pre-assembly just to test the alignment and fit of all components. Nothing is soldered yet. This step was just to make sure all standoffs, arms, and plates fit correctly before committing to wiring. The flight controller will be mounted on vibration-isolated grommets, and I'm planning to connect the ESC using soft silicone wires to minimize noise in the Gyro. As you can see, I'm also using external nuts instead of built-in nuts inside the carbon fiber. That's actually safer for FPV builds because the internal ones tend to loosen up over time. Before I start wiring the main MARK4, I built 2 additional frames. These are purely for practice. The idea is simple. I want to test different frame sizes and layouts to get more comfortable with assembly and soldering before I start the final build. It's a great way to save time later. If something goes wrong, I'd rather make the mistake on a practice frame than on the main drone. Each frame helps me plan cable routing, ESC positioning, and camera mount adjustments, basically turning the whole process into muscle memory. So that's the MARK4 V2 10-inch, a strong, lightweight frame that's perfect for anyone looking to build a reliable long-range FPV drone. In my upcoming video, I'll be building a custom flight controller based on the ESP32, combining a low-cost IMU sensor and a simple yet effective control system. The goal is to show that you don't need expensive hardware to start experimenting with drone technology. You can create a fully functional flight controller using affordable, easily available components. This project is perfect for DIY enthusiasts, students, or anyone curious about how drone stabilization and flight algorithms actually work. By using the ESP32 platform, we can keep the total cost extremely low while still achieving impressive performance and flexibility. I'll walk you through the process step by step, from wiring the IMU, coding the control loops, to getting your motors spinning in a stable and responsive way. If you've ever wanted to build your own drone without spending hundreds of dollars on commercial flight controllers, this series will be a great starting point. And as always, if you enjoyed this video or want to see more about DIY drone electronics, flight control systems, and low-budget builds, make sure to leave a like, subscribe, and stay tuned for the next episode.